This is the electric flame scallop, also known as the disco scallop or disco clam. It's a sessile marine bivalve in the family Limidae, and even though it's in the name, they're not actually scallops. The family Limidae are a group of bivalves known as phyoclams. If you're like me, this may remind you of something that seems kind of familiar. The electric flame scallop is characterized by the light display along the edge of its mantle that flashes seemingly like an electric current, but they don't actually produce any electric current or even any light. In fact, they're the only known bivalve species to have a behaviorally mediated photodisplay. It was previously believed that the light display was the production of actual light, like bioluminescence. Instead, it was found to be the reflection and scattering of surrounding light. At the edge of their mantle, they have a very thin tissue with two distinct sides, a highly reflective and light-scattering side, then a red, light-absorbing side. They perform the display by curling and uncurling the lip at the edge of the mantle. You can see on the video that the tissue appears to be fluttering in order to flash. This perceived flash is the result of densely packed and highly reflective silica microbeads that are absorbing and reflecting surrounding light. So why do they do this? Scientists have hypothesized that this characteristic is behavioral. Up until very recently, it was assumed that this behavior was used for four main functions: to recruit juveniles to settle nearby, to send signals to others about danger, to attract food, or even to deter predators from attempting to attack. This video shows an electric flame scallop going up against the mantis shrimp, which are known for their punch that produces a cavitation bubble which has the strike force equivalent to a .22 caliber bullet. When approached by the mantis shrimp, the electric flame scallop presents its light display, and the optical illusion puts the mantis shrimp into a catatonic state. However, recent studies have led scientists to believe that the flashing behavior is designed to respond primarily to the presence of predators and food. The eye structures act more like photoreceptors, and their lights are not bright enough to be picked up by conspecifics. They're unable to form images, but they can sense changes to light in the environment, and that ultimately determines their flash rate. So you're probably wondering where you can find one of these. Disco clams have erupted in popularity among aquarium owners, so now you can find them in exotic fish stores all over the country. But if you're looking to see them in their natural habitat, you're going to have to go to the tropical waters of the Indo-Pacific. They tend to live in shallower water, around 30 to 50 meters for the most part, wedged into cracks and crevices of coral reefs. Despite not being as well studied as scallops, scientists have been able to tell us more and more about these as years go by. Still, there's so much to be uncovered about them, but one thing that is certain is that they are the grooviest bivalves in the sea.